Okay, brother, so looking at this particular question, so that let's say we should um design an integral controller to yield a 10% overshoot and 5 second settling time. So those are the questions. So the first thing is that for us to start this, we need to get the desired dominant poles, and for us to get the desired dominant poles, then we need to solve for the poles. So since we are given the overshoot, we are going to use the formula for the overshoot to determine that. And you know this formula, which is zeta is equals to minus ln percentage overshoot, then 1 all over square root of pi squared plus ln squared percentage overshoot. So we are going to use this formula to determine that. So from there, this is going to be minus ln, the 10% is 0.1, right? So this is going to be 1 all over this, then pi squared plus ln squared 0.1. So if we solve these, we are going to get 0.59 0.5912. So having obtained this, then we are going to look for this angle theta. We know that this zeta is the same thing as, that is cos theta is the same thing as zeta, this zeta that we got just now, and from here it means theta is equal to arc cos 0.5912. Okay, so 5912, and if we solve these, we are going to get our theta to be equals to 53.76. Okay, so having obtained this, we have obtained our theta. First of all, to understand this very well, let us draw the pole diagram. You see, this is the location of the desired pole. So they are like this. This is the position of the imaginary axis pole, the imaginary parts of the pole, while this is the real part. A is the real part. That angle theta that we just obtained now, this is it. So if we determine the value of A and B, then we have determined the poles of the system, the dominant poles. So since we know theta, then we can use that to determine it. So first is that we need to determine value of A, and we can get that from the settling time. You know, settling time is TS, which is 4 all over A, and since we are given settling time to be 0.5 A, we can determine that to be 4 all over settling time, and that is 4 all over 0.5, which is 8. So we have determined A to be 8. So having determined A to be 8, you know, from here, you know, at TS is 0.5 second, rather. Here is 0.5 second from the question. You must have seen that. So that's the 8 that we got here. Now we will now use this diagram, which is tan theta is equals to the value of B. You know, this is B. and this is A in this diagram. So tan theta here is going to be B over A. So from here now, we'll just get tan theta. So tan theta is going to be equal to B all over A. Since we now know A, so we can determine B is going to be A tan theta. A tan theta. So A tan theta now from here, so B will be equal to 8 tan 53.76, right? 53.76. So from there we'll know the value of B. The value of B is now 10.9. So we have obtained the value of B. So if we now want to represent them, if you look at the diagram once again, you will see that if you want to represent these poles here, they are on the left hand side of the plane. So because of that, so they are going to be represented like this. So the dominant poles. So the dominant poles. So they are minus A plus or minus JB. So and that's going to be minus 8. A is 8. Then plus or minus J. B is 10.9. So those are the dominant poles. So those are the dominant poles. So we also need to get the third pole. We need to get the third pole. And to get the third pole, we have to locate it far away from the dominant pole so that it should not have effects on the dominant poles. So we'll choose that we'll choose the third pole to be more than 5 times the real parts of the complex of these dominant poles. So and that is A. So it has to be more than 5 times A. 5 times A. A is 8 already. So 5 times A, that's 40. So we have whatever number we have to choose must be more than 40. So we decide to choose 100. So let's say this is going to be 100. So this is going to be minus 100. So it is further away from the dominant poles, and because of that, it will not have any effects on the dominant poles. Okay, so at this point, so we'll just choose the third pole. So third pole. So third pole. Third pole is going to be S plus 100. So from these 3 poles now, we can now determine our characteristic equation. S plus 100. So we can determine our characteristic equation from here. So characteristic equation so it's going to be S plus this the complex poles first plus J 10.9, then S plus 8 plus J 10.9, right? So that's going to be the first 2 poles, the dominant poles. Then the third one will now be S plus 100. S plus 100. So we equate it to 0. So this is our characteristic equation. So we'll now expand this characteristic equation now. So to expand this, we will see that this one is a complex conjugate. That is S plus 8 plus J 10.9 and S plus 8 minus J 10.9. Now this S plus 8 is the real part. S plus 8 is the real part. Then 10.9 is the imaginary part. So we need to find the complex conjugates. They appear as difference of 2 squared, right? So we'll now need to write them like that. S plus 8 square, when you say minus, then 10.9, if you want to do the square of j, is going to be minus. So when minus multiplies minus, it's going to be plus. That's why this has to be plus, and this will be 10.9 square. So we'll put this in a bracket. So that's the complex conjugate. Then the s plus 100, that one is still here, equals to 0. Now we'll now expand this. Now s plus 8 is going to give us s squared plus 16x, then plus 64. And if we find the square of 10.9, we are going to get 119 points 119.137. So with that, now we are now going to expand further. So this is going to be plus 100 equals to 0. Now if we add 64 and 119 together, so that's going to give us s squared plus 16s plus, so adding this to 64 and that will give us 183.137, right? So into s plus 100 equals to 0. Now this is now going to be expanded further. So this is now going to be expanded further. So we use this s squared now to multiply s and 100. So that will be s cubed. So if we use s squared to multiply s and 100, so this is going to be s cubed plus 100s squared, right? 100s squared. We also use 16s to multiply s and 100. So that will be 16s, that will be 16s squared, then 1600. Then we also use 183.137 to multiply s and 100. So that will be 183.137 s, then plus, so when this multiplies 100, it's going to be 183.13.7 equals to 0. So that gives us this. So at this point in time, we'll now add them together, the ones that are addable. So we add them together, so ones with the same degree. So 116, that will give us 116 s squared. Then 1600, this is supposed to have s. That is 16 times 16s times 100 is supposed to give us 1600s. So 1600s plus 183.137. So when we add those ones together, we are going to get 1783.137 s, then plus the third, which is the one that does not have s, which is this one, the last one. So that's going to give us 183.13.7, right? So having obtained this, we will now, we have added everything together, so it is now in its complete form right now. So we'll set this one aside. Let's call it equation 1. Let's call it equation 1. Let's call it equation 1. Let's set it aside. Now let's come back. Let us form our integral controller equation. Our integral controller equation is x dot and xn. So that's the integral controller equation. So it's now equal to A minus BK. Then this one is minus C. Then BKE. Then 0 here. So with this obtained, so this is X and this is Xn. So this is our integral controller equation. So, and this is equal to plus 0 1 0 1 arrow, right? 0 1 arrow. Okay, so having obtained that, oh, now having obtained that arrow, so having obtained, so this is the integral controller equation. So with this integral controller equation, we can now extract our, from the question that was given. If you look at that question, so we are given a matrix. That matrix, we have not used it, so this is where we want to use it now. So after we have formed our character, we now want to form an equation from this matrix that is given. So which is minus 1, minus 1 0 1, and all these three matrices. So let us label them and put them down so that we can know what they are. So we know that from the question, this is A. We know that this is A. Our A is equal to minus 1 1 0 2, and our B is 0 1, right? Then our C is equal to 1 1. So now that we have obtained this, we now know that we can form our equation by putting everything in this equation that we wrote above. We can put them, so because we have already gotten everything that we need there. So what is our equation going to look like? So the equation is going to look like this: x1 dot x2 dot and xn dot, and that's going to be, you put this minus a rather, we put it inside the matrix, minus b, right, bk, and our b is 0 1, where our k is k1 and k2. So they will be in the row matrix, is a row matrix. Then the other, the below is going to be and as the 1 1, while on this side we will have this one to be bk, that is b as 0 1, then ke, then 0 will be here. So we just arrange them like that and put them inside this matrix. Okay, so when they are in this matrix, we'll now, so it's going to be x1 x2 xn. Okay, so plus, this is going to be 0 0 1 arrow. So that's our equation. So this equation now is what we now want to simplify. So we want to simplify this equation. Okay, so if we expand this equation like this one as it is now, if we open this, if we multiply b and k1 k2, multiply that column matrix and the row matrix. So we are going to get x1 dot x2 dot xn dots. So this is going to be minus 1 0 1 2. Then if we open this, if we multiply this, we are going to get 0 k1 and 0 k2, right? So, and this is going to be minus 1. It's going to be minus 1. Okay, while this is the one on this side, this bk, this is bk, so it's going to be, this is going to be 0 ke, while the one here will be 0. So let's go ahead and deal with this matrix first. We can put others in our explanation later. So this matrix, let us subtract this from this. So let's subtract this from this. So this is going to be minus 1, and 1 minus this is also going to be 1, and then this will be 0. Then 0 minus k1, so you have minus k1. Then 2 minus k2, so that will be 2 minus k2. Then the second one will be ke. Now the next one will be, so the next one will be minus 1 here, minus 1 here, and 0 here. So we have formed the matrix that we need now. So this matrix now that we need. So with this matrix, we can now form our Si minus A. So having gotten this matrix now, this is this matrix, we call this that's now our new A, which is, let's call it A prime, or let's put a cursor, just put a bar across it here. So let's call this one A bar. So our A bar. So with this A bar now, so we can now we need to get the determinant of this A, of Si minus A, to be able to get this now. So it's going to be Si minus A bar. So we want to get Si minus A bar. So, and what is Si minus A? What is Si? So what's our Si? Si from here is, we know what our Si is. So S0 0 0 S0 0 0 S. So with this one now, then minus A. So A is what we have just obtained now. So we'll put that one there too. This is minus 1 minus K1 and minus 1. Then we'll put the middle row, the middle column, put it there. So that's 1 2 minus K2 and minus 1, then is 0 KE and is 0. So when we subtract these two from each other, we're going to get this. We are going to get S plus 1, then minus 1 and 0. Then this is going to be K1. This is S minus 2 plus K2. Then this is minus KE. Minus KE. While this one is 1 and this is 1. and this is S. So now that we have obtained this one, we are now going to find the determinants of this particular matrix. So to get the determinants of this matrix, so we are going to find the determinants of this Si minus A bar now. So determinant is going to be determinants of Si minus A bar. So that determinant is going to be obtained like this. Now let's look at this very well. If you look at this, we see that this is going to be, if you want to find the determinant, this is going to be positive, negative, positive. We now take this first entry, so we cross this and this. We now multiply major diagonal, then minus minor diagonal, then forming the to get the determinant. So this is going to be minus, then if you cross it, what is left is K1 and S, then 1 and KE. So you use major, multiply the major diagonal and subtract it from the minor diagonal. So from there we'll be able to get what our determinant will be. So our determinant is going to be S plus 1 into bracket S into S minus 2 plus K2, then plus KE. That's plus KE. Yeah. So from there, we'll now determine then the second on the second column. So we get that one to be KE, K1S plus KE. Right. So if we now expand this determinants, so we are going to expand this determinants now. It's going to be S plus 1. So opening this bracket is going to give us S squared, then plus, then minus 2, and K2. They are the same, they are constants, so we'll put them together, multiply them by S, that is opening the brackets, then plus KE, plus KE. Okay, so with this now, then this one is going to be K1S plus KE, plus KE. And now at this point, we'll now expand further. We need to make sure this is fully expanded. So we have X plus 1. So we can still expand further. So if we use X to multiply, if we use X first to multiply the first S in this first bracket, to multiply the 3 terms inside the brackets, so that's going to give us S cube, now plus, then S multiplying this bracket, the inner bracket, minus 2 plus KE. So this is going to be S squared. Sorry, this is X, this is K2. Mistake. This is K2. Okay, so now that S now multiplying KE, so it's going to be plus KE S, right? So now that has been multiplied now. So now the second term, which is this one now, which this one inside will now also multiply it 3 times here. So that gives us the exact thing in the brackets, right? So that will give us plus S squared, then plus minus 2 plus K2 S plus KE. right? Now we now also put the other ones there plus k1s and plus ke, right? So put those ones too there, k1s and ke. So k1s and ke. So now that we have fully expanded this, we now need to collect like terms that are like the ones with the same degree. So we'll collect them together. So s cube standing alone, it does not have pairs. So this minus 2 plus this, and it has also it also has an s squared down the line, that is plus s squared. So we have that. If we add those, if we bring them together, we're going to get minus 2 plus k2 plus 1 s squared, down plus the ones with s, the ones with degree s. So we also need to put them together. So that's this ke, right? Ke, and the one, these brackets, this minus 2 plus k2. Then there's another one down the line, this k1s, right? So we also need to include it here, k1, all of them, they are having s. Then the next one is the ones with constant coefficients. You see that that's ke and ke, so that's 2ke, 2ke, so equals to 0. So this is our this is the characteristic equation that will now form from this. Now with this characteristic equation, now we'll now compare this together with the other one. If you look at this very well, so we'll compare with the characteristic equation that we got earlier. So which is this equation 1 that we got earlier. So the characteristic equation that we got earlier, we'll now compare them together. So with equation 2. So let's call this one equation 2. So we'll now compare equation 1 and 2 together. So comparing 1 and 2 now together, so this is going to be let's bring equation 2 here, equation 1 here, so that we can see them and compare them together properly. So this is going to be s cube rather, s cube plus 116 so this is going to be s cube plus 116 s squared plus 1783.137 s, then plus 183 113.7, so equals to 0. So this is the equation 1 that we got earlier. So we now compare them together. So comparing, so we say comparing 1 and 2, or let's say matching 1 and 2. So match 1 and 2 together. So this is going to give us the expression in the brackets, which is k2 minus 2 plus 1 is going to give us minus 1. So from the first expression, the one with s squared, so that means k2 K2 minus 1 is going to give us 116. So from here, K2 is going to be 117, right? So that's K2. We have obtained that one straight away from there. Now the second one, which is second expression, the S coefficient, the one with coefficient S. So that's going to be KE plus K1 plus K2 minus 2. So that's going to be equal to 1783.137, right? So let's leave that as equation 4. Also, the third coefficient, that is the coefficient, the constant coefficient to KE. So the constant coefficient to KE, we see that 2K is equal to 18313. So the constant coefficient, so that means 2KE is equal to 18313.7. So that means KE from here is going to be equal to this divided by 2, right? And that's going to give us 9156.85. Okay, so now that we have obtained this one, now we now want to, we have obtained KE, we have also obtained K2. So from that equation 4 we can get K1. So let's go and get K1. So K1 from here is going to be equal to, so K1 is going to be equal to 1783.137. So plus 2 plus then minus K2 minus KE, right? So if we substitute the values of K2 and KE in this expression, so we are going to get our K1 to be minus 7488.7. So those are the three values that we need to get. So now we have our K1, our K2, and our K3. So those are the KE, right? So K1, K2, and KE. So that those are the three controller equations that we need to get.